Okay, so we were going to notify new users. Am I going to enhance? No. Hey. So we're going to talk about Abacus and, oh, look, there's a heart. There's a heart. Tap the heart at the top. Okay, so go ahead and share. I don't know. How do I share? No, if I hold it, and then I share. Interesting. That's cool. So I'm going to share. What am I sharing? I don't know what I'm sharing. Interesting. So share. Copy link. Okay, so there we go. So encourage more users to share. So invite others to go live. I'm going to be talking about Abacus. And so here is my Abacus. I am talking about Abacus because what is it? It's the difference between this and this. There's the difference, right? The difference is we have 3 different types of Abacus. And welcome. Hi, welcome. We're talking about Abacus, and Abacus is about counting. What we're going to do is we're going to learn how to read the Abacus. So on this Abacus, we have 1, 2, 3, 4. Anybody have questions? So this one is 4. So if I look at it, how do I know it's 4? Because this is the bead that's touching that makes it count, right? So when it counts, this is what happens, right? This is 4. This is all 0. How do I know? Because none of the beads are touching. None of the beads are touching this beam that makes it counted. So this is what 4 is. So if I look, that's 1, that's 2, that's 3, this is 4. And so welcome, everybody. Welcome. If you have any questions, let me know about Abacus. What is this thing? This is a counting tool. And this counting tool helps everybody who wants to learn how to count. And so when we count, this is 4. How do I know? Because this is the beam, right? This beam shows how everything is touching. And when it touches, that means it's counted. So then if this is 4, this will be 5. Hi, everybody. Woo! So this is 5, and then this is 6. How do I know this is 6? Well, when the beads are touching this beam, this is counted. So when it's counted, this is 5. All of the top beads has a value of 5. So if I look, this is 5, this is 5, this is 5, this is 5, that's 5. They're all 5s. These are all 5s. But these all have a value of 1. So when I count, it's 5 and 6. How do I know? Because it's 1 bead on top, which is the value of 5, and then this is a value of 1. So this is 6, and then this is 7. Hi, everybody. Go ahead and please like and share my live. How do I know? So when I counted, it's 5, 6, 7. So in the question, well, here's a question for you, those that have been following, what number do you think that is? It should be like easy, right? Because if this is the value of 1 and I just add 1 more, what would be this number? Anybody know? Go ahead and put it in the chat. Hi, everybody. Come on in. Anybody know what number this is? So if I look, it's 5, 6, 7, 8. And so all the beads at the top has a value of 5. All the beads on the bottom has a value of 1. So when I look at it, I see it's 5 plus 3. So when we look at it, we can actually start decomposing, right? So we have 5 and 3 is equal to 8. Ooh, I don't know if that's going to work. Okay, maybe I'll do that. So then if I look, I could add 9. So this is 9. How do I know? Because it's 5, 6, 7, 8, 9. Hi, everybody. Welcome. We're just talking about the Abacus and how this is a counting tool. This helps understand how to do math. So when we look, that's 1. I'm going to change to a marker because I can't see that. So this is 1. So that's 1. Right? This is 2. So I have 2 beads. 1 and then 1, 2. Right? Same thing. And then 3, that's 3. 1, 2, 3. Anybody have questions? Go ahead and put it in the comments. If I have 4, when I have 4, this is 4. How do I know? This is my beam that's being counted. So when I have 4, 1, 2, 3, 4. Notice I have 4 items here. It would be the 4, same thing for that. Now, the tricky part is this top bead. This top bead has a value of 5. This will always be the value of 5, no matter what you do, right? So when we do 5, right, that's the top bead. But then it's kind of like, doing these building blocks, these other manipulatives, right? We have 1, 2, 3, 4, 4, right? 1, 2, 3, 4, and then 5. So we have 5, right? And then this one is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the kids, they know that this is 10. That's the same thing. The kids will always know that this is 10. So it kind of translates. I mean, we don't know because we are still learning. But when the kids start off young and they start learning how to read the abacus, they'll know that this is 5. And it's not something that, it's difficult to understand. So when we count, we have 6. So on this one, we have 1, 2, 3, 4, 5, 6. Now, the cool thing about abacus is that it's easy to see that this is 6, whereas this one, I would have to break it up. If I do this, I'd have to count it, right? Or if I do this, it's easy because then we split it. So then we do 7. So we add one more, right? So that's 7. And then this is 8. This is 9. So then what's after 9? Well, if this is the ones column, right? This is the ones column. When we write 10, right? This is the ones, this is the tens. Same thing on the abacus. This is the ones, this is the tens. So now we're at 10. Hi, everybody. Welcome, welcome, welcome. Go ahead and let me know if you have any questions about how to read the abacus. So then we have 11. When we do 11, just like on the abacus, we have 1 and 1. What you gonna do? 1 and 1. Hi, hi, hi. Welcome. If there's anybody have any questions, let me know. So if you notice, this is the ones, right? This is the ones column, and then this is the tens column. Tens column. Just like on the abacus, this is the ones column, and this is the tens column. So then if I do this number, anybody know what this number is? Go ahead and comment if you know what this number is. Wow, 112 people, 117. Wow. Thank you, everybody, for joining. Hi, everybody. So if we know, nobody is mentioned, okay, so then we have 12, just like how we write it, 1 and 2. So if this is the ones, this is the tens, this is 1 and 2. So when we count, right, this is 2 and this is 1, 2 and 1, and then 3, right? We have 13, and then we have 14, right? So this is 14. This is the ones column, and this is the tens column. But see, the thing is it's a gentle reminder for people who are looking at the abacus. So this is a gentle reminder that this is 14. So this is 14. So what happens after 14? Well, all the top bead has a value of 5. So this will be 5. This is 15. 1 and 5. So that's 15. Anybody have questions, let me know. We're talking about abacus and how to count on the abacus. So we have 16. How do I know? This beam is what makes it count, right? So because these beads are not touching this beam, these are all 0. This is touching the beam. This is counted. So these beads are counted. So we have 1 and 6. How do I know? Because this is a value of 5. This has a value of 1. So we have 6, 7, 8, 18, 19. I forgot the 10. So it's 10 and 9, right? So it's 19. Oh, hi. How do you do multiplication? Well, the one thing you need to do is you need to really learn your math facts. So when we do multiplication, let's see, something easy, right? We do 8 4 times 3. Okay. So when we do multiplication, thank you for your question. When we do multiplication, thank you for your question. Okay, wait, hold on. Just checking to see if there's any more comments because everybody's coming in. Okay, so multiplication. What we're going to do is we have to find our starting point. To find our starting point, the reason why, so then we know where to put our beads when we start counting. So the one thing we need to do is we need to learn 3 times 8. When we do 3 times 8, it's 24, right? 24. So when we add it to the abacus, we have 2 and then we have 4. Okay? And then what we do here is 3 times 4. So 3 times 4 is 12. So what do we do here? Well, we have to add 12, 1 and 2. There's not enough beads to add the 2. So what I'm going to do here is I'm going to use a formula that says to add the 1. So to add the 1, I have 5 take away 4, and then 2. So that's how you do it. That's how you do multiplication on the abacus, if that makes sense. So the way we do it is we still need to learn our multiplication. On the abacus, we could do we have to do like a few numbers that we have to start remembering how to like maneuver the numbers. So you could do skip counting. So we do 5 and then 10 and then 15 and then 20 and then 25 and then 30 and then 35 and then 40. But this is all about understanding the number patterns, right? So if anybody has any questions, so in looking at this, anybody know what number that is? Hi everybody, come on in. Let me know if you have any questions. So this is about talking about abacus and what we're doing multiplication. So that was one of the questions. How do you do multiplication on the abacus? Doing the multiplication is doing the result on the abacus. So then here, this number is 40. How do I know? Because this is the ones and this is the tens. So we have 4 and 0. And that's what it is. It's 4 and 0. So then with my book, I have this book that talks about abacus. This one is about, it kind of focuses a little bit about children, learning how to do numbers. And so we start off with understanding what the numbers are. And then here, which is I've already done it because I'm teaching a class. I have an online class that teaches abacus. And so what we do is we just trace the number and we know what the number is. The idea here is to see what the number is for the abacus. So if this is 1, that's 1. And they were supposed to translate from the picture to the physical to the actual symbol. So the idea here, and then making sure that they understand what 2 is. So they have the symbol, and then they have the physical, so that's 2. And then it's just to go forward to understand how to read the abacus. So when we have 3, right, we have 3 on the abacus, and then they have to find 3 on the picture. So if you can look, I don't know if you can see. So if you can look, if you look at these pictures, where do we find the number 3? That doesn't look like 3, but this is what 3 looks like, right? So what we would just have to do is, for the kids, they would have to do a hide and seek. So they would have to seek the hidden number, which is 3. So the 3 looks up here. I don't know if you can see that. There's a 3 up there. So looking at the number and looking at the physical, and just trying to relate the two. So we are looking at the abacus. But this is all about bead recognition. And when we do it, that's 4. Again, we're looking to see what number looks like 4. So we try to get them to understand how to relate the number 4 on the physical abacus to the number 4 on the paper. So this is an idea to like, what's it called? Representative. So this one is just a little game, right? They just color in whatever color they want. It doesn't, whatever key that they wanted, whatever color. And then from here, they have to match and follow the path to go down here. It doesn't matter what path that they go into, but the idea was then to get them to understand how to read these numbers and how to match the numbers to this here. I actually really like this activity. I like mazes. I like mazes and puzzles. So a lot of my book is about mazes and puzzles. This one is about matching. So this one here is we count the number of items, right? And then we add it and we show it on the abacus, right? So if I have 3 apples here, there's 3 apples, and then there's 3 beads on the abacus. And so here, what we're doing is I'm trying to get them to to write the number and then find the abacus to go and then write the number again. So that's my book. This book is available on Amazon, and we talk about abacus and the numbers. So when we go through, they're learning. So this book specifically helps to concentrate on like how to count forward and how to count backwards and how to count, what's in between and stuff. So this one is kind of cool because there's a color pixel. So they would have to find the number, right? And this one here is about number recognition. So you see the bead. So there's 2 beads up here, and then they would have to find the number and color it in. So this is about bead recognition and number recognition and how to relate the numbers of the abacus to the paper, because it's a translation thing, right? So this is 4 and then this is 4. This is 0, this is 0. This is 1, this is 1. This is 3. Can you see that? And then that's 3. Yeah. So that's my book. So in my book, I broke it up into separate lessons. So this lesson, we're actually talking about 5, 6, 7, 8, 9. Why? Because now we're adding higher than 5. Because this book, what I did is I made it systematic. So when they were doing it, when I was doing it, when we count, we have 5 and then we have 6. So this one is 6. How do I know? Well, I have one bead on top, which is 5, and then this is 6. And so the kids are able to decompose. It's really quite cool. So you have 6, right? And then here we have 7. Oh, yeah, that's right. I was going to change this a little bit. So the idea here was to find out where the number 7 is. And then if it's not 7, how do you make it 7? So this is 6. We add one more bead, right? That's what this is. We add one more bead to make 7. Because what we want to do is we want to count up to 7. And then this is 8. So we have 5, 6, 7, 8. Yeah. So if you have any questions, let me know. I'm trying to check to see if I have any questions. Let me know if you have any questions. And going through, we have this number. What number do you think that is? That number is 38. I'm just checking to see if there's any questions. Hi everybody. Welcome. Oh, there is no 5. No, there isn't a 5. No, there is a 5. Ha! This is 5. So this top bead is 5. And this 5 gets represented. So when we do 4, we all know in Abacus that this will always be 5. So this is 5, this is 5, this is 5, this is 5, this is 5. So this 5, the top bead will always be 5. So then when we start counting, we have 5 and then we have 6. And then we have 7. We will always count 5, 6, 7. And then 8. 5, 6, 7, 8. So yes, there is a 5. It's just the bead itself, like there's no actual like physical numbers. So this is a Chinese abacus. If we look, that's 5. But then it gets a little redundant because this is also 5. Oh, I don't know if you could see that. So if you look, let's see if we could do side by side. So when we count on the Chinese abacus, right? We have 1, 2, 2, 3, 3, 4, 4, 5. It's great to have 5, right? It's nice to be able to see that there's 5. 1, 2, 3, 4, 5. But then on this abacus, we know that this is 5. This will always be 5. So on this Chinese abacus, this is 5. So there's 2 ways to do 5. And so this one is actually more efficient because there's only one way to do 5, whereas this one has 2 ways to do 5. And your brain has to remember this is 5 or this is 5. So if we can continue to count. Ooh, hi everybody. Welcome. I'm just checking to see if there's any comments. Any comments? Any questions? I'm just checking to see my messages. Okay, so we have 5. This is 5. This is 6. This is 6. 7, 7, 8, 8, 9, 9. And then what's 10? Well, just like when we write, 10 is like that. So we have the 10 and the 0, right? How do I know? Because there's this dot. This dot tells me that this is the ones place. So this is 10. But on this abacus, this is also 10, and this is also 10. So it's a little confusing because now you have 3 things on this abacus. You have to do 3 things to remember what 10 is. Whereas on this abacus, it's only one way. There's only one way. This is 10. This will always be 10, no matter what. How do I know? Because there's a dot. This dot helps me know what place value we're going to start at. So when we start at this place value, this is ones, this is the tens. This is the ones, this is the tens. Just like how we write. Right? We have the ones and we have the tens. We don't say it with kids, but this is what we know, right? So when we write it, it's the same thing with the abacus. So then the question is why do we have the different dots? Well, you can start from here. That's not a problem. Or you could start from here. It doesn't matter. What does that mean? Well, it just depends on how big your numbers are. If you think you're going to be dealing with a lot of decimals, you could start here. So if I have 1, right, I have 1.20 or 1.02. So now we start doing place values. We're starting to do columns. we're starting to do place values. Yeah. So if I continue on with this thought, let me get some new paper. So we're talking about decimals now. So on the abacus, we can actually do decimals. It's just easier if I could do it this way. So then we have, so because my dot is over here, my decimal is over here, so I have this number. So this number is 1.02. So just like here, I have 1.02, right? 1.02. Yeah. So then if I do this, right, it's 1.004. Okay, so that's if I start here. If I start here, it's the same thing, but then now I just have all these other beads, all these other columns to use. So if I start here, and this is my 1, and I have 25, right? So then I have 1.25. That's what this is. So then here, when I add in this number, it's 5. So now I have 51.25. So knowing that this right here between these two columns is a dot, is the decimal. Anybody have any questions? Let me know. So go ahead and heart, and share my live if possible. So we're talking about Abacus and how it works with numbers. And so now we have the ones, we have the tens, we have the hundreds, right? And then we have the thousands, and then we have the 10,000. And then, so then from here, that's why we would start from here, because now we have more columns to do place values, which is different than this. We have a bigger abacus here. We have a lot more columns. So with this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 columns. 13 columns. So if we start here, it'd be ones, tens, hundred, thousands, 10,000, 100,000, 1 million, 10 million, 100 million, 1 billion, 10 billion, 100 billion, and then what, trillion? So that's 13 columns right here. There's another one which is longer, and this is I think 21 columns. So those are the difference. But the only difference is just that it's longer, just more numbers really. So, but that's what it is. Anybody have any questions? Let me know. Hi everybody, come on in. Welcome. So go ahead and like my live. This is all new to me. This is all so new to me. Thank you so much for joining me, and we're talking about the abacus and how to read the abacus. So when we're counting, it's 1, 2, 3, 4. These all have the values of 1. I almost forgot the words. This has a value of 1. So this is 1, 2, 3, 4. The difference between this column and this column is that this column, these beads are touching the beam. This beam tells us that these numbers are being counted. So we have 4 and then 5. This will always have a value of 5. Let me know if you have any questions. So we have 5, this is 5, that's 5, this is 5, this is 5. Just like this is 4, that's 4, this is 4, this is 4. But on top of it, because we know that this is the ones, and when I move it to 4, this is actually 40, right? This is actually 400. How do I know? Because this is 0, this is 0, this is 0. So we have ones, tens, hundreds. And then this is 4,000. How do I know? Because here, I wanted to designate that this dot right here is 0. Sorry, ones. So ones, tens, hundreds, thousands. So this is 4,000. So we got 5, 50, 500, and then 5,000. So then we do 6, right? How do I know this is 6? Because it's 5 plus 1. 5 and 1 is 6. So 6, 60, right? 600, 6,000. Let me know if you have any questions. Hi, everybody. Welcome. We are talking about abacus and how we're counting on the abacus right now. And then later on, I'll start adding on the abacus. Let me know if you have any questions. So here, if I do 6, right, we have 7. So this is 7, and then this is 8. How do I know? 5, 6, 7, 8. We start counting on from here. Why do I do that? Because we only have 4 beads here. 4 beads here, we don't have any more beads. So we have to use the 5. This 5 is always designated as designated as 5, no matter where you are. This is 5, but it just happens to be 0.5. This is 0.05. So this will always be 5 no matter what. So then we have 5, 6, 7, right? 7, 8, 9. So anybody have any questions? Give me a number. Anybody give me a number. Give me a number and I can show you what it is. Let's see if we have a number. I have a number. Somebody's number is Rosie Lopez. Rosie Lopez. 6, 8, 9. So we have 6, 8, 7. So there's Rosie. Ooh, 5, 1, 2. Okay, so the number is 150000. So do we have it? Do we have enough beads to do this? No. So we have to use this one. So if I'm going to use my bigger abacus, I'm going to tilt it and I'm going to make it all clear. So knowing this is 0, 0, 0, 0, 0, 5, 1. So that's 100. Oh, is that right? 0, 0, 0, 0, 0. Yeah, that's right. Because I'm going to start here on my ones. So this is my ones column, right? Ones, tens, hundreds, thousands, 10,000. Oh no, I was wrong. 10,000, 5,000, here. So that's what it is right there. 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. So then this is 150,000. So that's the number. So let me know if you have any questions. Oh, here, Popeye has a number 10179. 10179. So this is my ones. I have my ones. My 7, I have 7, right? 9, 7, 1, 0, and then 1. So that's what this number is. 1, 0, so 10,179. Yeah. So if you have any questions, let me know. So what we're doing is we're counting on the abacus. Oh, hi. Oh, good, Jay. I hope they have any questions. So I do like if you have any comments. Oh, so those are the comments. So that's the difference between this one. I mean, I could do it here if I did the 0 here. So it'd be 0, 0, 0, 0, 5, 1. I mean, it's a little confusing because now the dots on this abacus doesn't match up. So I'd use a bigger abacus. But, depending on how old your child is or how many numbers you want to use, right? Sometimes the numbers get really big, and so we would have to use this longer one. So the difference between the 3 abacus is that this just happens to be longer. This has how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23 columns. So the number can be 23 long. I mean, I could put it in, but then it'd be difficult to show you because the way the camera is. All right. So that's what we're doing. Anybody have any questions? So yeah, we did a little bit about counting, and then we also understood how to do the decimals. And this is upside down, right? So the other reason why we want to be able to hold the abacus, because the numbers, the beads are so easy to maneuver and move. So that's why you use your left hand to use the abacus, to hold the abacus, and you use the right hand to calculate. Because they say that the brain does the calculations on the left hemisphere. Is that right? The left hemisphere. Yeah. So what I just did is I cleared it out, and I noticed in American school, because I'm in California, so in American school, they actually don't start from 0, but in the abacus, we actually start from 0. Why? Because we need to clear our abacus. We need to make sure that it's nice and clean so we can actually utilize it and do it, right? So then we can then start going into counting what 1 is. 1, 2, 3, 4. And then because there's no more beads at the bottom, I have this bead. This bead always is 5. Just like this, I don't know if anybody knows what this is. This will always be 10, right? So the idea of substituting items and quantities is not a difficult concept. You just need to know, right? So just like how the kids are taught that this is 10, the kids are taught that this will always be 5. So it's kind of nice because then you can count all on one. In the brain, we can only see like so many digits. So I know that this is 6. But here, if I give you this, what number is that? Well, I got to count it. 1, 2, 3, 4, 5. I need 6, right? 6, right? Or sometimes they use it like this, right? This is a die. This die is the same thing. It can be representative, right? So this is 1. This is 1, and so that's 1, right? I have 5, that's 5, right? Oh, I should use this one because it's easier to see. So we have 5, right? 5. So the 6 is 6. Well, the cool thing about the abacus is that you can go to 7. On the die, you can't go to 7. You got to use another die, right? So that means you got to do this to do 7. So then we have 8, right? Then we got to find 8. But it doesn't make sense because 6 is a difficult number to like visualize, whereas 5 is easy. Because when we count on the abacus, right, we do 5. Let's count by 5s. 5, 10, 15, 20, right? 25, 30, 35, 40, 45. Oops, sorry, 45, right? 50. How do I know? 50, 55, 60, 65, 70, 75, 80, 85, 90, and then 100. Oh no, 95. I got 95 and then 100, but I don't have any more columns. But if I started here, I could do it, right? And then I can count all the way here. Let me know if you have any questions. What we're going to do is we're counting on the abacus. Go ahead and like and share if you're interested in more about abacus. I'm talking about abacus and how to count and utilize it as a teaching tool. Teaching tool and learning how to use it with the numbers. So what we do is we do arithmetic. Like we do adding, subtracting, multiplication, and division on the abacus. And so all of this is to help, solidify what the numbers are, right? So when we're counting, we have 1, 2, 3, 4, right? Just like on the die, right? And notice with the die, we have 1, right? And then we have 1. And then here is my, what do you call it? A number block. Yeah, they call it number blocks because they do dots and sticks. That's what they call it. Dots and sticks. On the abacus, because I teach abacus, right? So we have 1. So this is 1. Or we could do 10, right? It's nice on this because you could see the quantity. You could see that this is 10. On the abacus, that's 10. This is more representative when we write, right? Let me know if you have any questions. So when we do 10, you notice it's 10 and 0. So this is the tens place. And then this is the ones place. Right? But on the die, we only have up to 6. So we have on the die, we have 6. And then we have 4. So what does 4 look like? That's what 4 looks like. How do I know? Now, notice I did that. Well, this is 40 because this is my dot. This dot helps me. This dot tells me that I started at the ones place. This dot tells me that this is the ones and this is the tens. So this would be incorrect, right? It would be actually this. If we're talking about place values. So the middle is tens. The middle is not tens. It depends on this dot. If you see this dot, that's what tells me that this is the tens. So here is my dot. You could start here if you want. This could be your ones and this could be your tens. So it all depends relatively on where you signify where your ones is. So the ones will always be on the left side. The tens will always be on the left side, if that makes sense, right? If I have a bigger abacus, right, my bigger abacus will also have the dots, which is kind of cool. And you could start anywhere on this abacus. So you could start here as the ones, you could start here as the ones, here or here. So it's not necessarily in the middle. If it's a bigger abacus, like this is a bigger abacus, I would like to start in the middle because depending on the, place value, so you could whole numbers and you could do decimal numbers. So that's the difference. But because this is a smaller abacus, I like to use the small ones for the kids because they like, it's colorful and it's fun, right? And it's small for it's small in their hands. Whereas this is a little bit bigger and it's kind of boring, right? So that's why I like to use this one. But yeah, it all depends on this dot right here. If you could see it, there's the dot. Yep. So, if you have any questions, let me know. I wasn't taught how to use the abacus, so this helps. Oh, you know what? I didn't learn how to use the abacus when I was a kid. I actually learned it as an adult. My dad went to Korea. I'm not Korean, I'm Chinese. But my dad went to Korea on a business trip, and this lady was like, you gotta learn abacus. And so he learned a little bit about abacus. He's like, oh my God, I hope my kids will learn it. So, show you the number 9. So this is the number 9. I'm going to count it, right? So it's 1, 2, 3, 4. And then this has a value of 5. So 5, 6, 7, 8, 9. So this is 9, and then this is 9, and then this is 9. But because I'm talking about place values, this is actually 900, right? This is actually 90, and then this is 9. Easy. And it's kind of nice because the kids will be able to visualize it, and then they can start moving the beads. So when we start adding, right, we can start adding. We do 2 plus 2, or we do 1 plus 3, or we do 4 plus 5. And it's just an easy way to translate into adding and subtracting. So, going back. Oh, yeah, same here. I never knew of any of it. You know what? Same here. I didn't know what an abacus was until I was old. I'm old now. My kids all know abacus because I learned abacus and I taught them. So I have 3 boys and they all learned the abacus way. And then did it help? It really helped. I think it really helped. In California, we have the Common Core, and my older son started with Common Core, and it was a really easy transition to learn from Common Core to abacus. Wait, it's actually less oh my God, it's so less complicated. You know what? Oh my God, yeah. So when we're learning it, when I was learning it, I didn't have to learn my doubles. You know, I had to learn your doubles, right? Remember that thing you had to do 4 plus 4 is equal to 8? Oh my God. So one step after learning, how to add and subtract on the abacus, right? We're going to do simple. It's called simple because there's no formula. But now there's this 4, right? We have no more beads to add the 4. Right? So what does that mean? Well, in school, we're teaching the kids what the 5 frame is. 1, 2, 3, 4. 1, 2, 3, 4, 5. We're teaching the kids what the 5 frame is, which is great. It's fantastic. So if I color in 4 beads, right? How much can I make 5? Right? What is this? Well, it's 4 plus 1 is equal to 5, right? So that's great. That's fantastic. That's all that they do. But in Abacus, we actually take it one step further. I'm going to utilize this 5. So what I'm going to do is I'm going to move this over here. So in algebra, right, we actually have to manipulate things. So this is like an introduction to algebra, because what's going to happen is we're going to rearrange this equation, and we're going to do 5 minus 1, because we want to make sure that this arrow, this equation is balanced, right? So now we have a balanced equation. What does that mean? Well, when we add a 4, we need to add the 5. But 5 is too much, so we have to take away the 1. So they understand the idea of balancing the equation. And I was like, oh my God, that's crazy. So this, okay, so that was the other thing is, in school, we are taught result driven, right? So we know what 5 plus 3 is equal to 8. So here's 5 plus 3 is equal to 8, right? And then what was the other one? It was 4 plus 4 is equal to 8. And that was the doubles. But see, in Abacus, it's different, right? But then you do 6, right? The next one is 6 plus 2. Well, on the Abacus, is there enough beads to add 2? Yes, there is. So I don't need to learn another thing here. I just need to move the beads. So there's 6. Oh, I noticed. Oh, hi, everybody. Welcome. There's a lot of comments, and I'm just going to. Oh, okay. So can you multiply? Yes, you can multiply with it. I'm so sorry. I wish I had, there's a lot of questions. Okay, let me see if I can go back. Can you multiply with it? Yes, you can multiply with it. The idea is to learn your multiplication facts. But let me continue on with my thought. I learned in early years of grade school. That's what I'm saying. It looks like it's more it's actually not intimidating. Yeah. When I started learning it, I was like, oh my God, I can't believe it. There's a lot of I noticed that there's a lot of abacus, but it does the same. Yes, it does the same function. But if you're on a Chinese abacus, you could use it too, but you would have to just use the middle parts because Chinese abacus is a little bit redundant. You need a better explaining of what you're doing. It's too confusing. It's too confusing? Okay, I will learn. How do you know the numbers? Oh, it's not the colors of the numbers. This is just the way it looks. So ideally, the abacus will look like this, and then you would just have to use it. Right. So it's not the colors that makes the difference. It's the the movement of the beads. So when we count it, we have 1, right? So if this is 1, and then on my abacus, on this colorful abacus, that's 1. The idea is to move the number, to move the item. So this is 2. So I have 2 beads here, just like I have two blocks, right? 2 blocks, 2 beads, 2 beads. And then this one, but we don't need to do this one because this one's a Chinese abacus. Okay, so that's what it means with the colors. So the colors actually don't mean anything. It's just nice because it's colorful, and we all like colors. I like colors. So I mean, this is blue. What does the blue mean? I'm just. Anyways. So yeah, the idea is not the colors. The idea is the actual quantity. So on this abacus, I like it just because it's pretty. So the top is, so when we count it, we only have this. There's only beads. There's only four beads. So what happens to 5? 5 is all the top bead. The top bead is 5. So when we look, we have 5 or we have 5. But depending on our columns, right, we do place values. This is 50. This is 500. This is 550. So this is always going to be the 5. This 5 will always be 5. This top bead will always be 5. So then we do 6, 7, 8, and 9. Oh, yeah. And so the cool thing about it is if the abacus is bigger, you can have bigger numbers, right? We could do like billions, right? Because you have bigger numbers. But this one, you can only do so many. This one, you can only do 10,000. How do I know? Ones, tens, hundreds, thousands, 10,000. If I start here, and then that's the other thing, right? So what happens here? Well, these are like the dimes. These are the coins. So it'd be $1, right? Ones, $1, 25. So that'd be $1.25. So you could do like money on this thing. So that's why this dot is over here. So you could do like money on the abacus. Teach them money. So then if I do this is $1.75. How do I know? Because there's a dot. I imagine that there's a dot right between these two columns. Just like how we write, right? $1.75. We have a dot. This is the ones column, right? This is the tenths. And then this is the hundredths, right? So it's the same concept. 1.75. 1.75. Yeah. Oh, okay, great. Let me know if there's any other questions. What did you say about the top bead? So the top bead is a value of 5. The top bead is a value of 5. So when we count, right, and we do say 8, right, we have 5, 6, 7, 8. So it's easy to see 5, 6, 7, 8. Ooh, sorry. And then there's 9. So I hope that helps. And then, okay, great. Which question are you referring to? Oh, it's what's the top bead? The top bead is, what number is that? This is 5. So we have 5 and 4. So the great thing about this is we can start decomposing. So what does that mean? Well, in school, the kids are taught what 4 and 5 is. So when we add 5 and then 4, and that makes 9. But in Abacus, you could see that 5 and 4 makes 9. If you take away the 5, it's a 4. If you add the 5, it's 9. So yeah, let me know if you have any questions. How do you know where the ones is if there is... How did you know where the ones are? Oh, okay. You know what? If there is no dot, then you can choose any column. It doesn't matter. But what I notice is you have to keep track. So like this one has no dot, right? So then let's say you do a calculation, right? And you walk away, but then you come back. You're like, oh no, was it 5, 6, 7, 8, 9? Was it 960 or was it 96? So the reason why we have a dot, which makes it like easier to understand, is so we know if we were to walk away, we know where we started, if that helps. So if we have, let's say I did this like 96, and then I walk away and I come back, right? I know that this is my 9, this is my 6, and this is my 9. So it's designated, right? But the idea is to to make sure that we label it. Just like, when we label in everything, it's nice to know. Because if we don't label it, then it's hard to remember. Because I don't remember a lot of things. I don't like to remember. Oh, multiplication. So we do multiplication. Well, okay. Multiplication. So we have our question. Let's do 84 times 3. So this multiplication, I'm going to change it to a different color. Let's do this color. So in Abacus, we need to find out what our place value is, because that's how we're going to know where we're going to put our answer. So we have 1, 2, 3 columns. 1, 2, 3 columns. So we're actually going to start from here. And then the idea is to know, we actually have to remember our math facts. So 3 times 8 is 24, right? So we add 20 and then we have 4. So this is, in school, we're taught, it's called distributive property. So now, what do we do now? Well, what we do is we do this. We have 3 times 4. 3 times 4 is equal to 12. So we have the 1. There's not enough beads to add the 1. This is where we start doing our fact family. Our plus 5, we have to add the 5, take away the 4, and then we add the 2. So that is how we do multiplication on the abacus. Thank you. I really like my small abacus. It's nice and colorful. I like this abacus because I like the different layers of the beads, only because it's nice and pretty and cute and fun, whereas this is a little boring. I feel like it's a little boring. I mean, I've been seeing this for like 20 years and I see this now. It's like, oh, I'm going to get this one instead. So thank you so much for the compliment. Yeah. So going back to the multiplication. So when we multiply, we're actually, I think what they do so when we're doing it, we're doing distributive property. In school, they do it for like this, right? Is that what they're doing? I don't remember. And then they do the same thing, but then it's a little different because I know when I was a kid, I did it like this, right? So it's 12, and then we have to carry the 0, and then we have to do this, right? And it's 4, and then 2, and then it's a little on the backward side. So when we add it, it's 2, 5, 2, just like this, 2, 5, 2. Yeah. So, yeah, I learned the vertical way. Yeah. So I learned it the vertical way too. On the abacus, they changed it. How I forgot it's called. Oh yeah. It's called distributive property. Yeah, that's what they did. So I'm just looking at the comments and questions. She's showing us how to use the in times. Oh yeah. So let me know if you have any questions. I will, same way vertically. Yeah. It's confusing for the abacus. Oh, it's still confusing for the abacus. Well, it's confusing for the abacus because we don't know it, right? So if you start looking at it and understanding it and using it for what it is, it's a tool. Because, doing these can be confusing too, right? Like, how do you use this and how do you break it? So the idea is that the abacus is a tool, just like this is a tool and then this is a tool, right? The die is a tool, the abacus is a tool, and then the number blocks is a tool. So it just depends on how long I've been doing it for a while. I taught my kids how to do it. I teach students how to do it. I've been teaching abacus for about 20 years now. 20 plus years. And so, thank you for that. Thank you. I've reached my goal. So it just depends on like how often you do it, just like everything else, right? Just like having this pencil. This pencil is difficult to use if you know how to use it. So the idea is, start from understanding how to count. So it's 1, 2, 3, 4, and then 5, and then 6, and then 7, and 8, and 9. So when we do 10, this is 10. 1 and 0. And then this is 11, this is 12, this is 13, 14, and then 15. So I hope that helps. Let me know if you have any questions. I'm confused as well. I can understand, but I get lost. We get lost because I'm going too fast. I can go slower. That's not a problem. I'm so sorry. I've been talking really fast because it's so exciting. I'm so excited for Abacus. And I'm so excited that people are asking me questions about Abacus. Let me know. So let me take it slower. So when we do our numbers, right, we have our ones, tens, hundreds, thousands, and 10,000. So that was the idea. So let me know if you have any questions. I hope that makes sense. And okay, so But that's the other thing. Like, I'm like totally giving you everything about Abacus, but really take it slow, right? The idea is to understand what the beads are and what it looks like. And so when I have my book, right, it goes through understanding what the number is, and this is for kids. I geared it towards preschool, and what it was is just to understand the bead recognition, right? So the idea is to just understand what it looks like to do the beads. Where does it start? Where does it start there? Why does it start there? Because this is like, I've been talking about this for about 40 minutes. So, I mean, that's why. So when we talk about the abacus, we have our dot, and this is where it starts. So when we count, it's 1, 2, 3, 4, right? Because we joined late. Yeah, I mean, I've been on this for about 40 minutes now, so I'm like doing further on. But let me start over. So here, when we count, we want to do where this dot is. This dot is our ones place. So our ones place is 1, 2, 3, 4. And then this is 5. So when we count, this will always be 5, that will always be 5, this is 5, and then that's 5, right? But then it does depend on what your place value is. So this is the ones, the tens, the hundreds. Just like how we count, right? And we write. When we write, let me show you. When we write, we have 10, right? So this is 10. 0 and 1. Do we break it down and we tell the kids that this is the tens and then this is the ones? Just like how we write it, we have it on the abacus. So then we have 2, 3, 4, and then 5. 6, 7, 5, 6, 7, 8, 5, 6, 7, 8, and then 9. Okay? So I'm just checking to see if I used to left to right. Do the dots tell you? Oh, okay. So the dots is the place value. Left to right, right. So if this is my ones and then I do this would be 909, right? So 909. Well, that's not a good number. So let's do another number. Let me find another number. Okay, let's do this. 384. Well, this is my hundreds, right? We are all taught that this is hundreds. This is my tens. Ooh, I don't know how to spell. And then this is my ones, right? So on the abacus, this is my ones. This is my tens. This is my hundreds. So when I do it, it's 3, 8, and 4. So the first thing is to understand what the place value is. 0 is nothing on the that touches it. Yes, correct. So in abacus, we actually start from 0. When we start from 0, because in school, it's funny. In school, we don't start from 0. In school, we start from 1. But in abacus, we have to start from 0 because then we have it nice and clean. So when we have it nice and clean, we know that this is 0 because all of the beads are not touching this beam. This beam is what tells us what beads are being counted. So when the beads are being counted, this is what we do. We do 3, 8, 4. Yeah. Oh, yeah. Oh, yeah. Oh, sorry. Oh, okay. So we have a number here. We have a number 8, 846.45. So on this abacus, right, we're going to clear our abacus. It's going to be 0, right? We're going to clear our abacus and it'll be 0. So we have, I don't know we can start here by the ones. Usually, why would I want to start at the ones? Just so I know where my place value is. So it's 6, 4, 8, 1. Okay? So this is my decimal. My decimals are right here, right? Right between the two, just like here, right between the two columns, right? Right between these two columns is 4 and 5. So that's what the number is. Great. Yeah, for sure. No problem. So then we have, for here, we could do a dollar sign, right? We can do money. because there's two decimals over here, right? So that's what this is. Okay. The blue, actually, not blue. It's the top bead. So this and this are the same. So the top bead will be 5. So this is 5, and then this is 5. Okay? So just like how, I have another abacus, and this is a longer abacus, and this is 5. So it's always the top bead. It's always the top bead. No matter what you're looking at, it's always the top bead. Even if I show you the Chinese abacus. The Chinese abacus is the same. It's just has 5 beads on the bottom and 2 beads on top. But the 2 beads is still 5. So when I do the Chinese abacus, let me do the Chinese abacus. This is 5, but that's 10. How do I know? 5 plus 5 is 10. So that's the difference. Does it go by sections? It goes by columns, just like how we write. Right? It goes by columns. You could do by sections. So this is the ones and this is the thousands. You could do that. I mean, there's the dots for it to help you understand, where it is. So then this would be 100,000, right? So the dots are there to help you anchor. Not anchor, but label. That's what it is. The dots are help to label what. Let me clean my camera. The dots are to help you label and mark the where the place value is. So we have ones, 1, 2, 3, 4. So this one, my dot's over here, right? Not in the middle, right? This is, if you look at it, this is the middle of the abacus, right? But because my dot is not in the middle, it's over here. Because I realize it's because these 2 columns is like the cents. Right, that's why they have here. So you do like money on this abacus. Yeah, that makes sense. So we do. So the question is 1. So I'm going to start from here. 6, 4, 8, 1, and then 45. Yeah. Yeah. Oh yeah. So here's a question. Can you do equations with them? Yes. You should, yes, we have to learn equations in order to do it. So then this is where we do the plus 5. Yes, so, okay, here's a question. I have like numbers. Let me see if I can find my numbers. Oh, here's a question. What number is this? So I'm going to do this one. Can I do this one? So what number is that? Anybody know what number it is? Do you really show me this? I'm so confused. Okay, I'll show you in a little bit. Let me see if anybody knows what this number is on this abacus. Who knows this number? So remember, yes, Danny. Yes, perfect. Yes, airy sheep. Yes. No, wait, I'm sorry. No, it's 1, not a 6. The 6 looks like this, right? So it's actually 10179. Yes, Patrick. Yes, Nate. Yes, Sarah. Sister Sarah. Hello, Sister Sarah. I like that name. Sarah. What's going on? Oh, what's going on, Mr. Himothy? We are counting on the abacus. So let's start counting on the abacus just to understand what it is. What we're going to do is we're going to start from this dot because this dot signifies our ones. So when we count it, we do 1, 2, 3, 4. Okay? So when we do 4, where is 5? Well, the top bead is always going to be 5. So we have 5, okay? Just like this. This is not any color. So we're going to do 1, 2, 3, 4. I chose this because there's a dot here. And then this is 5. So this is 5 and that's 5. See, it's the top bead. Any bead that touches the beam is counted. So when we do it, it's 6, right? How do I know this is 6? Because the bottom beads has a value of 1. So when we count, it's 5, 6. So we can count on 5, 6, 7. We added 1 bead and we get 8, right? 5, 6, 7, 8. And then we get 9. 5, 6, 7, 8, 9. 4 plus 5 is 9. So that's counting on the abacus. But where is 10? Well, if you noticed, when you're writing the number 10, right? We have our 10s and we have our 1s. Notice we have 1 and 0. So that's 10. Yes, the top bead will always be 5, no matter what. It's called the top bead, not the blue bead, because when I do this, this is not blue, right? So it's always going to be the top bead. The top bead will always be 5. So when we count it, right, we have 11. How do I know? Because it's 1 and 1. 1 and 1. What you gonna do? Anyways, sorry, that was a baseball chant. When my kids were young, we put them in baseball. But anyways, so 1 and 1, right, makes 11. And then 12. How do I know? 1 and 2. Because this is the ones, this is the tens. Oh my goodness. Have I been on for an hour already? Okay, let me do this. Okay, I'm going to head out pretty soon. Or maybe I keep going because this is crazy. Like, I have never seen so many people before. Hi, everybody. Hi. Hi. Give us another number to guess. Okay, I'm going to give you another number to guess. Let me see. Oh, you know what? I'll do this. See if anybody... There. Who knows that number? Let's see. What number do we see? So, okay, let me continue. So this is the ones, this is the tens, this is the hundreds, right? So when we're counting, just like we do when we write, yes, mostly everybody got it. The 5, we cannot forget the 5. The 5, so it's 254. You're absolutely right. Yes, the second beads and the third. So the top bead is 5. Yes. The second and the third beads are 1s. Yes. So the bottom beads are 1s. So when we count it, okay. So here's some subtraction. On the abacus, let's subtract it because we've been counting up. Let's count backwards, right? When we're counting backwards, we want to take away. And notice I'm taking this bottom bead. So we do 3 or 4, take away 1. Notice when I'm counting, I'm taking away 1 bead, right? So here I have 3, take away 1. I do this bead. So it's 2, right? And then 2 take away 1 is this. So the idea is to know that when we take away 1 bead, we get the answer. So the difference is being able to, because we've been counting up. So we just keep adding. So, that was the one thing is like teaching the children that we're talking about the 1 bead, not this is 1 and then this is 2, because this is also 2. Right? The idea is to know that these items are 2. This item is 3, not that this is 3. If that makes sense, right? So the idea was to say that these are the beads that we're moving. The number of beads we're moving is this. So we have 2. This can be 2 or this is 2, right? This is 2, and then this is 2, right? So when we're doing 1, right? This is 1, 1, 1, 1. So when we add it all together, it's 4. I hope that makes sense. I feel like my stuff color-coded will be hard to different it. I feel like it would be hard to differentiate it. You could use the regular one. I like the colors, but we could use the regular one. So here we do 1, 2, 3, 4. We could do that. I mean, if the colors are too much for you, that's true, right? Like if colors are too much, it gets confusing. Like, oh, I don't know what's going on. You could get this one, which is really good too. I mean, the reason why I don't, because I've been looking at it for 20 years. So I saw this, I was like, oh, this is nice and colorful. But no, you're absolutely right. Like in the beginning, if it gets too confusing, you could use something that's a little bit more, subtle. There are others. There's another one where it's like a single color too. But the single color does help just to get an idea of what we're trying to do. So when we're counting, this is my dot. If you see my dot right in the middle. So when we're counting, we could do the same thing. We could do 1, 2, 3, 4. And again, if we take away 2, we could take away 2 beads like this, right? These 2 beads. Or if it's 3 and we take away 2 beads, it's these 2 beads. Right? These beads are not labeled like the ones that are colored. I could see I could see how it can be confusing with the colors. I just thought it was pretty. But don't forget, I've also been doing abacus for a while, so I just thought it was like, it's all right. But no, I mean, if the colors are confusing, then you can use something that's like one color, and the one color is just as good. I mean, a lot of the kids, like, all over the world, they use the one color anyways. I mean, I think these colorful beads are new. So, anyways, so going back, we have 4. Now, when we count, because these beads are touching this beam, this is counted. This is not counted. None of these columns are counted, right? So then we have 5. This will always be 5. So the top bead has a value of 5. No matter where you go, it will always be 5. So this is 5, and then this is 6. So how do I know? 5, 6, when we count it, right? This is 1, right? And then this is 5. So, okay. Give another example. Could you do another 100 example? Yes, I can do many examples. I have so many examples. Oh, you know what? Oh, no, you wanted 100 examples. Okay, let me give you 100 example. Because I was going to do, so I had I created a new worksheet, and I was like kind of happy about it. But let me, let's see. Oh, you know what? I'll do this. Okay. What number is this? What number is that? Oh, okay. So we do have a question. 13, take away. Oh, that's a minus. Okay. So we have to do that. If we spend for a minute, it's nice to see you actually learning. Yeah. I'm just counting on the abacus and showing how to use the abacus. And I have an online class, and I also have a book. I have a book that I created about abacus because it's the greatest thing next to sliced bread. Oh my God, I just missed it. Okay, sorry. Back to here. The number is this. So we're going back to this. Okay, so that's my question. What number is this? Yes. Okay, so one of the question is, how do you take away 13, take away 4? Okay, so this is going to get a little bit complicated. So what do? We have 13 minus 4. Okay, the question is 13 minus 4. Now, this is the different part. This is the more advanced. So let's talk about it. Is there enough beads to take away 4? Okay, that's the question. Is there enough beads to take away 4? No, there's not enough beads to take away 4. Now, in school, we are taught the 5 frame. 1, 2, 3, 4, 5, right? 4 plus 1 is equal to 5. Why am I talking about this? Because these are steps that we need to understand when we start doing abacus. The question now is there enough beads to take away 4? No. So what's the next one? Is there enough beads to take away 5? No. Now the other question is there enough beads to take away 10? Yes, there's enough beads to take away 10. This is where we start talking about the 10 frame. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10 frame. Now, remember, in school, we're taught that if I need to use 4, right? 1, 2, 3, 4, how much is left over? It's 6. So my question, how to make a 10 is like this. So in school, we are taught to make a 10. In school, we're taught how to group and regroup. In abacus, we take this and we change it around and we take away the 6 because we need to balance this equation, right? This is the equal sign. We need to balance this equation. So what we're going to do here is we're actually going to minus the 10 and add the 6. Because why? Because we want to take away the 4. To do that, we need to take away the 10, right? We have to regroup it, and then we're going to have to add the 6. Okay? So this is a little bit more complex, but this is the next level. After counting, after understanding the plus 5, it's understanding the plus 10. So when we do this, what we're doing is we're going to, if we want to take away the 4, we have to take away the 10 and then plus the 6. So this is a little bit more advanced. So basically adding in sections is another number. Adding is another number, yes, in a column, in the place value. So, absolutely no real gain. What? Why make something more confusing or absolutely no gain? There's an actual gain to it because knowing this foundation, I don't have to know what my doubles is, right? So what was my doubles? My doubles was 4 plus 4. Well, what's my doubles of taking away? We know to do doubles, but knowing this in doubles in school doesn't help. But knowing the foundational building blocks, this is actually very common because we can do the other way. 4 is equal to plus 10 minus 6. So if you notice, this equation is just the reverse of this equation. So knowing the foundational of this, how do you do a doubles minus sign? I don't know how to do that. So it'd be like 8 take away 4. 8 take away 4 is 4. But you had to know your doubles to get the 8. Whereas in Abacus, if you know the 4, how to manipulate it, you can move it. So that's the difference. Is it difficult? It's only in the beginning because it's a new thing. If it's a new thing, it's going to be confusing. Schools, it's something you could learn. Most schools don't teach Abacus anymore. I wasn't. No, actually, schools doesn't teach Abacus. There are specific school classes. Like I've been teaching Abacus for 20 years, but I have my own school. I have my own, center. And then now I'm trying to go online and I'm trying to show everybody else, the world, what an Abacus is. Because you see, like, if you YouTube Abacus, you see a bunch of kids just, do their numbers like this. But what they're doing is they're taking the numbers that they understand on the Abacus and they're manipulating it. That's what that is. So, okay. So yeah, I'm trying to teach. So my kids know Abacus only because I taught them. Did they take it to school? They took it to school, but nobody else understood it. But so then that's why I have my book that I created, because I'm trying to educate what Abacus is and how to do it. This one specifically is about learning how to add and subtract. And this one is knowing the numbers and how to read it. So when I added, I put in like a bunch of bead recognition. So they have representative and then the number itself, but then they can also use the abacus as well. So the idea was to, slowly introduce the kids how to use the abacus in relation to regular school math, right? So the transition, I'm trying to make the transition easier. So when we do this, right, the number is 2 on the abacus. How many, what number is 2? So you write the number 2 and then only color in the correct number. That's why the only 2 dogs are counted. Right. So the idea was to relate the number with the abacus. And then when the kids, and even anybody really, when we get understanding what the numbers are and how it relates to the symbol, like this is the symbol, like 5, right? We know how to read the abacus. So then the idea was how do you read the abacus and how to relate to it. So a lot of this is just, trying to figure out what the numbers are and so forth, right? So this is like follow the path. This is 8, right? And this is 6. Anybody know what number this is? What number is that? Oh, good. I'm so happy you're getting it. I'm so happy. Like, it makes sense, right? Like, it's so crazy on how easy it is. Okay, yes, 9. So this is 9. And then the idea was they can color in whatever color they want. And then they can find the number 9. So the idea was to try to figure out where that is. So then this one is, right? So that one is, what number is that? I want to learn this. I'm dyslexic. I wonder, yes, thank you everybody for commenting. Yes, this is 5. I wonder about dyscalculia. Like, I wonder would abacus actually help dyscalculia? Because I was trying to do research on it. I don't know what dyscalculia is. This is a new terminology for me. But for understanding like how to use the beads, I wonder if it's because it's physical and you could see the numbers move. So when you look, right, we have this and we have that. Or let's do this, right? The numbers, hopefully you could see it, right? What number is that? What number is this on the abacus? And I don't think it would be flipped, right? Because you could see the actual numbers. 20, yes, exactly, 28. right? It's 28. Hey, Sid, how's it going? I see you. Hi, everybody. Thank you for joining me. Thank you, everybody, for joining. Okay, so I wonder in dyscalculia, the reason why is because we're doing a lot of abstract, right? These are abstract symbols, 8, 6, 5, and so forth. But on the abacus, because it's physically here, you can't really mistaken that this 5 is that. It's 4. No, because you could see the quantity. So I wonder if dyscalculia, yeah, like I wonder, is dyscalculia really because we're pushing everybody to understand what these numbers are as opposed to physically seeing the numbers? So if I did this, right? If I did that, does anybody know what this number is? So if this is my ones, right? Ones, tens, hundreds, right? What number would that be? I don't understand. But 6, you can get 9. What number is this? There's this number here. Don't forget the hundreds. Yes, 524. 524. Oh, so the question is 13 take away 4. 13 take away 4. The reason why it's a little complicated because now we're doing a little bit more advanced in understanding the 5 frame and the 10 frame. So in the 5 frame, in the 10 frame, we are teaching children that 4 plus 6 is equal to 10. Okay? This is what we're doing. 4 plus 6 is equal to 10. Now, that's all they know is 4 plus 6 is equal to 10. This is a little bit more advanced, right? So if you can continue, if you can watch, it's great. If you can understand, that's fantastic. But there's no, I'm just saying that it's a little bit more complicated, right? So the other way to do this is the reverse of it, right? Minus 4 minus 6 is equal to minus 10. Because we need to take away the 10. Why? I have to think about this a little bit more, like how to explain it. Because this is not beginning math, right? This is not beginning like learning how to count. This is doing a little bit more advanced. Like there's building blocks. In Abacus, we have building blocks. Just like in regular math, we have building blocks on how to do things. So this one here, if I want to take away the 4, right? This is what I'm trying to take away. To take away the 4, I need to add a 6. To even out the equation. So if I rewrite the equation, it's like this. Minus the 10 plus 6. Why are we taking away 10? Because we need to take away 4. So if that makes sense, okay? So let me continue on. Oh, no, possum, it was 524. 524. 524. Okay, so going back to this, the idea is understanding how to take away the 4, right? But now we're going into more advanced understanding how to manipulate these numbers. So if I have 13, and my question is, do I have enough beads to take away 4? No. So what do I do? To take away the 4, I have to regroup. Oh my gosh, this maybe this would help. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 13. Okay, so we have this number 13. We have this number 13, right? We have a 10 and we have a 3. Now, in school, we are teaching children how to break this up, right? We have to break it up. So we have to take away the 10, right? And then what are we going to do? If I break this up and I take away the 10, right? I have 6. So now I have to add 6. And I add 6. Does that make sense? Show how to move the abacus. She came late. Can you show us how to? Yes, I will show you how to do the abacus. But does that make sense? So the difference between understanding, so that's what this is, like understanding that this is the 10 bead. I don't teach kids this. I teach kids this. Like they know what this is when they understand how to do this. So the idea is you have 13, you got to break it. You got to break this. To break it, you take away this 10. You take away the 10, you only need to take away 4, right? But then you have to add the 6. So when you add the 6, you add the 6. Does that make sense? No, because it's 9. The answer isn't 9. What? No. Because now it's 9. The answer isn't 9. Yes, it is. The 13 take away 4 is 9. Right? The idea was to break... The idea was to regroup. I guess that's what they call it. In regular school, they call it regrouping, and I think they call it grouping. Grouping and regrouping. So they take this and they separate it, right? When they separate it, and then do this. So this is actually a subtraction fact family. So now what we're doing is we're actually utilizing the fact family how to take away the 4. So in Abacus, we actually solidify going from working memory to long-term memory, how to manipulate the 4. No. Yeah. So we're all bad at math. We just got to look at it. That's all. Okay. So going back to counting. So moving the beads. So going back to counting, just to show everybody, this beam is what's being counted. When I have this beam, right now we're at 0. In regular school, we don't teach what 0 is. We teach where 1 is. But so on Abacus, we show what 1 is. This is 1. How do I know? This bead is touching the beam. This beam counts, helps me count, helps keep track of what the beads are being counted. So this is 1. This is 2. 1, 2. How do I know? Because it's touching the beam, and they're all being friends, and they're singing Kumbaya. I don't teach that to kids. Anyways, so this is 2 and this is 3, right? Because it's touching the beam. So this is still 0. These columns are still 0. That's 3. This is 3 and this is 4. And then, can you show it on the Abacus? Do the math there. Yeah. Yep. Okay, so now, what's after 4? We don't have any more beads. So we have to use the top bead. The top bead will always be 5, no matter what. This will always be 5. So we have 5, and then we have 6. We have 5, 6, 5 and 1, 5 and 6, 5 and 2, 5, 2, 7, 5, 6, 7. And then we have 8, and then we have 9. 5, 6, 7, 8, 9. We could, but it's kind of confusing for some of us. It's plain, all looks the same to me. Oh yeah, so that's why I like this one. I like it because it's nice and pretty. You could use this, it's up to you. Doesn't matter where you start counting. It does, because there's a label. Because I don't want to have to remember. If it's not labeled, I don't want to have to remember what column I'm in. So it's helpful to have it labeled, have it marked. So this is my marker, right? My marker will tell me that this is the 1s column. So anything on the left side, so this is my 1s, this is my 10s, right? Just like when we write, you can write a 0 here, or you could write a 0 here. But when you start putting it together, right, this is actually 10. You know what I mean? It's kind of like that. So you could start anywhere, but it's nice to start from a marker because then I don't have to remember what column I started on. So I would always start on a marker. Like there's these dots here. These dots are helping to help mark, where we count. And when we do Abacus, we actually do adding, subtraction, multiplication, and division. So when do someone need to use those? When they want to learn how to... when they want to do adding, subtracting, multiplication, division. So what happens is like kids, I would say kids, but even adults, like there's a whole program for seniors to learn and keep their mind active, because learning the Abacus way of like adding and subtracting and multiplication, division, it keeps their mind active. So, I mean, like as an adult, do we need it? No, because we have calculators. But when you're learning to do numbers, when you're learning how to count and subtract and add, like just like this, right? Do we need these when we're old? No, we don't. Right? We don't need these because we understand it. when we use Abacus, I would recommend when the kids are young. And then they can transition to multiplication. I mean, you could do multiplication with this, or you could do multiplication on the Abacus. It's harder to carry this around, but it's there. You know what I mean? It's an old, yes, it is an old calculator. How do you do, I haven't seen one in 5th grade. Yeah, I've always wanted one. They're everywhere. I even sell it. I should try to sell it on a TikTok shop. I haven't had one since 5th grade. Oh, so that's the difference. There's the Abacus that goes like this, and there's like a whole bunch of beads. They're different than this Abacus, because this Abacus also deals with place value. The Abacus that goes like this, it talks about quantity. So, okay, so the question is, can you do 30 times 7? Sorry, I'm just looking. So 30 times 7. Now, the difference between this is that we actually need to know our multiplication fact family, right? So how do we do this is we need to count how many columns to start. So I'm going to do on both of them. So I'm going to start here. So I go 1, 2, 3. How do I know? Well, I have to count these columns, right? 1, 2, 3. 1, 2, 3. So I'm going to start on the 3rd column. And then now what we do is we do 3 times 7. 3 times 7 is 21. So when I add it, it's 21. So we need 21, right? So because we do the place value, oh, no. Hi. Okay. Oh, I don't know how to do this. I don't know what's going on. No. Okay. So, where am I? Right, 200, yeah, because we had to count the columns, right? So when we count the columns, we know where to put our numbers. So we have 21, 210. Exactly. Okay. Whew. Okay, I don't know how to undo this. No, I don't know what I'm doing. This is a new thing for me. Okay, so I hope that helps. What happened? Oh, somebody came on board and I was like, I don't know what happened. So I don't know how to switch my... Why are they using 3? Why are you using 3 middle columns? Okay, the reason why is because if I wanted to do my decimals, I have these numbers to do decimals. Does that make sense? So here I use the middle because then I have all these numbers to do whole numbers and all these numbers to do decimals. That's why I start in the middle. You could start over here. You could start over here, but then you'd only have these numbers to be decimals. So what does that mean? So if I did this, can we does anybody know what number this is? If this is my ones, right? This is my ones. What number would this be? Oh yeah, possum. Yes. See, it's easy, right? When you look at it a little bit, it makes sense. So no, this is not 7. So what number is this? What number do we think this is? So this is my ones. My decimal is right here. If my decimal is right here, what number would these be? Anybody? 102. No, yes. 2.869. Yes, exactly. So that was the reason why I would do here. So then if I'm in the middle, I'm able to go all of these decimals, or I could do the whole numbers. So it just gives me flexibility. You could start and, oh, you can't see anything. Oh no. Maybe swipe left to close. Swipe left to close. I don't know how to do this. What am I doing? No? How do I uninvite? All right, I don't know how to do this. I'm like in this thing. What do you see? No? Don't invite. Okay. Okay. So I hope that makes sense. I've been on for a while. Maybe end the live and come back. You know what? How about I end the live and just come back tomorrow? I've been on for a while. I think I've been on for about an hour and a half, and I thank you guys, everybody. I'm going to try to be more regular. I hope to see everybody, and I'm so sorry that this is so I'm sorry. This is very new to me. Thank you everybody for computing for contributing. Thank you everybody for commenting and asking questions. I love Abacus. I hope this helps, and don't take okay. Thank you, everybody. And I will see you guys next time. Bye.